Hi, and welcome to this brief video on derivatives. My name is Callum Garrigan, and I will be discussing the history of where derivatives derive from, how to calculate derivative using examples, and real-world applications of derivative theory. But initially, let's define a derivative. A derivative is the rate of change in a value, object, or function, and can be easily represented as the slope of a graph at any given point. The discussion of who came up with the theory first was one of the biggest controversies of the early modern mathematical community. But before we get into that, let me introduce you to Sir Isaac Newton. Sir Isaac Newton was a mathematician and scientist who is credited with inventing calculus. It is an incremental development as many other mathematicians contribute to the idea. Isaac Barrow, Newton's teacher, stated that the fundamental theorem of calculus was present in his writings, but he did not recognize or emphasize his significance. As Newton's student, he presumably learned from him. It is also thought that the calculus was independently invented by Gottfried Wilhelm Leibniz as well. In the middle of the 1670s, he invented calculus. He claimed that he had the ideas around 1674 and published them 10 years later, in 1684. His calculus paper was titled A New Method for Maxima and Minima as well as Tangents, that is not obstructed by fractional or irrational quantities. It was 6 pages long, extremely cryptic, and difficult to comprehend. However, when Newton realized that Leibniz had the ideas for calculus which he himself realized in the 1770s, Newton responded by writing a letter to Leibniz to ensure that he received credit for calculus. He encoded a Latin sentence. The Latin phrase translates to, having any given equation involving never so many flowing quantities to find the fluxions and vice versa. Newton's thinking on derivatives was encapsulated in this sentence. He took that sentence and put the individual letters A, C, D, and E in the correct order. He stated that there are 6 A's, 2 C's, 1 D, 13 E's, and 2 F's. He arranged them in this order, which he included in his letter to Leibniz to establish his priority for calculus. Even if you read the sentence, it means nothing to anyone. Even a mathematician would be unable to deduce what he had done from the sentence's literal translation. He tried to establish his priority in that fashion. But what followed were accusations that Leibniz had read some of Newton's manuscripts before he conceived his own ideas. However, because Leibniz had published first, supporters of Leibniz claimed that Newton had stolen his ideas. You may be wondering how to calculate derivative now that you've learned about its history. Derivatives can be calculated using the following fundamental equation, where f of x is a function or value of the derivative you want to calculate, and h is a relative change in x known as delta x. These rules, on the other hand, can help you calculate a derivative much faster. We start with the exponent of or power rule. This passes to any derivative to the power of n equals the derivative multiplied by n to the power of minus 1. For example, the derivative of x cubed is 3x squared. A constant multiple rule argues a derivative of a function multiplied by a constant equal to the constant multiplied by the derivative of said function. For instance, x squared multiplied by 3 equals 3 multiplied by 2x, or 6x. For example, the sum rule for a derivative states that the derivative of the addition of two function or values equals the derivative of each functional value added together. The derivative of x squared plus the derivative of 2x equals 2x plus 2. This is known as the difference rule for the derivatives of subtraction. The derivative of one function or value multiplied by another is equal to the first function multiplied by the derivative. The second plus the derivative of the first function multiplied by the second according to the product rule. The quotient rule, on the other hand, is the same. However, with the division and serves as the inverse of the product and where the function is divided by the square of the second function. Finally, it is possible to gain the derivative of a derived value of function, and then a second derivative or higher is known as the higher order derivative. Sketch curves, motion problems, and other applications all use higher order derivatives. But where are all these derivatives used? If you've ever been in a plane, train, car, or roller coaster, you've probably experienced a derivative in physics. As a derivative means a rate of change in respect to time, and the object's movement in respect to its position is its velocity, meaning that the velocity is a derivative of position and acceleration is a derivative of velocity, and etc. As you can see here, I have created an Android application for this video in the programming language Java, and was developed in Android Studio. This app is using the accelerometer in my Google Pixel and displays the acceleration of the phone on a graph as I move the phone around. These are the Cartesian coordinates of the phone and the planes in which it is moving of x, y, and z. Again, with this phone application, it demonstrates the concept that the velocity is a derivative of position and acceleration is a derivative of velocity. Hopefully, you should now have a better understanding of derivatives, where they came from, and how they are applied in the real world. Thank you for listening, and goodbye.